This is a handout that is available for you guys, and it just has some different advice for the AP Calculus exam. It might be something to just take a look through, read it, and some of these. These are some of the information here is a little older, but I think the ideas are generally the same. Good advice. So Lynn McMullen, chief reader of the College Board, authored this. This is by Kennedy, who is the author of the textbook we use for Calc BC. But it's just I would just read through it as we're getting ready for our first practice test. It might kind of help you out. On the back, I'm going to go through a little more information on the back. Types of multiple choice questions. And know how to do these things on your calculator. So I'm going to focus on that part right here and just add some notes. One, you need to be able to graph a function. And so on your calculator, these are also things you got to do on free response questions number 1 and 2, which allow you to use a graphing calculator. So you need to know, you need to be able to graph a function in any window, know how to change the view window to fit the function. I mean, that's honestly one of the bigger challenges of graphing is getting a nice view of the graph. You need to be able to solve an equation. And there's a few different ways of doing that. Your calculator has a built-in solving operation. I've probably not shown this to you, but it's under Math 0. I don't like it because I find it kind of awkward to use, and there's some other drawbacks because you can't see where the answers potentially are. You don't know how many answers there are and where they're at, or if you found them all, even if there are more than one. So I personally would not use that. But you can also solve equations by graphing. So you could graph both sides separately and find their intersections. So that's one. But the third technique, which is my favorite in general, if I've already graphed two functions, then sure, I'll find the intersection of them. But graphing can take a lot of effort. And if I don't need a graph or see a beautiful version of the graph, put everything to one side equal to 0. And I graph that and I find its roots, its x-intercepts, its zeros. But when I do that, the window, I set y min to -1 and y max to +1 because I don't want to see the whole graph. I just want to see the x-intercepts. You set the x, you need to set the window still. You set the x values to the range of where you expect to get solutions, because you can get solutions outside of where you're supposed to be given answers. And if you graph those and you see them, you might accidentally put them as answers. You need to be able to find the numerical value of a derivative. So that's math. You can do it from the graphing screen, but Math 8 in Derive is my favorite way of doing it from the home screen. And you need to find the value of a definite integral. So that is Math 9 f and int from the home screen. You can find integrals on the graph screen, but it takes a while, and you only can do one curve at a time. On the home screen, you can do multiple derivatives, multiple integrals, all in one string of commands. Okay, the other part I want to talk about is top 10 student errors, which you might want to pay attention to. These are common mistakes. F double prime equals 0. That means you have an inflection point. No, not necessarily. F double prime has to change signs. And we usually use a line check. I mean, there's other ways that we might be getting that information, but this isn't enough that the second derivative equals 0. If it has an even power on it, it's not going to be a inflection point. fx has a maximum value whenever the derivative equals 0. Well, this is a critical point, but it's not absolute max or min just because of that. It could kind of plateau out. You have to, again, show that the sign of the derivative changes, and we often use line checks to verify that. So that just means it's a critical point, but it doesn't mean it's a max or min, absolute or a relative max or min for sure. Average rate of change of a derivative. Average rate of change, which, by the way, is a very popular way to say the average derivative or the average slope rate of change. This is mean value theorem for derivatives. And sometimes people think, well, if I'm going to average these two endpoints, let's just add them together and divide by 2, like a simple average. That is not the case. F prime average equals the rise over run f prime b minus, not f prime, fb minus fa over b minus a, rise over run. Don't put the derivatives in here. You're trying to find the average slope of the f graph to get the average f prime. Volume of washers, you can do pi big R minus little r squared all at once. Nope. You have to keep them separate, okay? Now, so you could do this r squared minus little r squared. You could combine them together. I mean, usually I write it like this: pi big R squared dx minus pi little r squared dx is two separate integrals, but you can combine them in the same integral and just have the pi once, but you have to square them separately. Number 5, separable differential equations can be solved without separating the variables. So these are all errors. These are top 10 errors, bad assumptions. No, you have to separate the variables before you integrate, before you solve. If you don't for your response, you're going to lose 5 or 6 points right off the bat. Doesn't matter what else you do. Omitting the constant of integration, especially in initial value problems. The constant integration, that's the plus c. People forget the plus c, which is bad. You lose a lot of points. Initial value problems, you lose even more points because then you're supposed to find the c value. Make sure you don't forget the plus c. That was an error that we made a lot sometimes on tests. Number 7, graders will assume the correct antecedents for all pronouns used in justifications. Like, hey, it is the max because it is positive, and so they won't. So try and be specific with your pronouns. Don't say it is positive. Say f prime is positive. The derivative is positive. Be very specific, okay? With your pronouns. Don't say it is or whatever. If the correct answer came from your calculator, the grader will assume that your setup was correct, even if you didn't show it. Nope. You have to show the setup. In fact, the setup is worth more points than the answer usually, and even if you have the correct answer, you'll lose lots of points if you don't have the setup. If you have the correct setup and the wrong answer, you'll get most of the points. Number 9, universal logarithmic anti-differentiation, meaning the idea that anytime you have something in denominator that you're going to do natural log. That is not generally true, right? It's only if you have the integral of 1 over something that is degree 1 in size, dx, then you get the natural log. But for instance, if it was 1 over x squared dx, that is not natural log of x squared. No, this is power rule. This is x to the negative 1 over negative 1. So be careful that you just don't use natural log anytime you have something in the denominator. It is, a lot of times that is the rule, but a lot of times it's not. The next one is taking the derivative function is just simply the derivative of the function. And the idea here is that there is an inner function and that you have to multiply by dy dx afterwards. the derivative of what's inside, you have to make sure you remember the chain rule. Chain rule is a very important process on so many of our problems. Also on integration, when you integrate and you're undoing derivatives backwards, use substitutions. One way to help you with making sure you deal with chain rule correct. A lot of times we can do it in our head, but make sure you don't forget chain rule. Make sure that you do the chain rule properly. So just some helpful hints. Read through the rest of this and use this to help you kind of avoid these mistakes yourself. Okay.